Hello everyone. Today we will understand TensorFlow fundamentals and how TensorFlow as a framework works. Let us start with some of the basic constructs of TensorFlow. As usual, we will try to first import TensorFlow library, TensorFlow as TF. So this is we'll import TensorFlow. We'll also import NumPy just in case we need NumPy for some numerical calculations. So we'll import TensorFlow and NumPy. The next step is to check the TensorFlow version. So I'm using Google Colab by the way, so we can run things here. So let me try to check the TensorFlow version. tf.__ version. This will basically give us a version that TensorFlow is running. So we can see that we are running 2.9.2. Okay. So now let us understand what are constants and what are variables. Any language or any framework you learn, first you will go through the very basic constructs. So we are doing similar stuff here. So TensorFlow has two concepts like constants and variables. So let me try to define a variable y equals tf.variable. So let me try to declare a variable. It has a value of 1, so we can see that TensorFlow gives the documentation as we type. So Google Colab gives the documentation as we type. So yeah, so this is how we declare a variable. Now let us try to see what we can do with this variable. I can assign another value to this variable. I have initially assigned a value 1. Now I can assign another value 2. Before that, let me just confirm. Yeah, let me just print out the value the y. There we go. So we can see that the variable has is of type int32 is a value 1. Now let me try to assign another value to the variable y.assign. Now we can see that the value has been reassigned and the variable has been reassigned with the value 2. So this is what variables do. You assign a value and then you can reassign a value, right? So this is what we mean by variables could be reassigned. Now let's look at constants. Let me try to assign variable x equals tf.constants value 1. So let me try to run this. There we go. Okay, did some error. Let me see what is the error. Has no attribute constant. Okay, it's a lowercase c. Okay, so I have created a constant, and now the similar way, let us try to reassign a value 2 to the constant and see what happens. x.assign value 2. So I'm trying to assign another value to the constant. Let's see what happens. Okay, there we go. We got an error, which basically means that object has no attribute assigned, so we cannot reassign a value to a constant. So this is how a constant is used. So where this constant variable used, we'll see in future videos when we try to build a model, but right now we're trying to understand what are the basic constructs of TensorFlow. Now let us try to create a constant from a NumPy array. It's very constant to mix NumPy and TensorFlow. So let me try to get a NumPy array, np.array of, let's say I give some values 3, 5, 8. So I'm trying to define a NumPy array. Okay, let me try to see the value. There we go. You can see an array has been initiated for us. It's initialized. So now I can create a constant out of a NumPy array. Let me say n equals tf.constant of x. So basically what is happening here is I'm having a NumPy array and creating a TensorFlow constant from a NumPy array. Let's see what n looks like. There we go. So we can see that a tensor has been created of a NumPy array. Okay, so this is how we various ways in which we can create a constant. Now let's understand the most important concept, which are tensors, right? TensorFlow, as the name suggests, it works with tensors, but what the hell is tensor? So let's look at one-dimensional vector. The two-dimensional, there are three things, okay? One-dimensional, two-dimensional, and whatever, three-dimensional. So let's look at first. I think I missed a one-dimensional here. So let me look at the one-dimensional vector. Okay, let me look at the one-dimensional vector tensor. Okay, so now let me say x equals tf dot 1s of 5. Let me some value I'm using. So t, and thereby I'm also seeing that there is some concept called, like, if you had used numpy, then numpy has numpy dot zeros, numpy dot 1. The easy method, convenient method to create array of zeros and ones. TensorFlow has a similar concept. If you say tf dot 1s, it creates a vector of given shape with all ones. Okay, so let me try to run this. Let's try to see with print x and see what happens. How does x look like? We can see that it has a shape 5 comma. Okay, float type is float 32 x array. Now if you look at the shape, right, let me look at the shape individually. X dot shape, right? So x dot shape gives us a TensorFlow 5 of shape 5. Okay, this is a one-dimensional vector. Okay, this is how a one-dimensional vector looks like. Now how do you know it's one-dimensional? Because 5 here is a number of elements in the array. We have 5 ones. How do you know it's one-dimensional? So a tensor has a property by name ending. N stands for n dimensions. So if I print ndim, there we go, we see 1, which means this tensor basically has one dimension. Okay, it's a simple array, one-dimensional vector is what we call as. Now let's look at two-dimensional array, two-dimensional tensors. Let me declare or create a two-dimensional array tf dot ones. I'll follow the same approach. Let me give a two-dimensional matrix as while creating this. Okay, let me print this, print x, and see what happens. Oh, there we go. Okay, so here we can see that the shape is 5 comma 8 as we had given. Let me again print x dot ndim. Okay, this gives us a value 2. So as we know, as we can observe, this is a two-dimensional matrix, right? Hence we have 2 dimensions to this tensor. Now let's look at a 3-dimensional tensor. Similar one, tf dot ones. Let me give 3-dimensional 5 comma 8 comma 2. So here this is not 3-dimensional. If we observe the what I give here, this array 5 comma 8, this array itself doesn't have multiple dimensions, but it is creating a, when you give this to a tensor, it is creating a 2-dimensional array. Similarly, if I give this 5 comma 8 comma 2 itself is not, what it means is I am telling TensorFlow to create a tensor which has 5 dimensions. I mean, it has 5 rows, 8 columns, and then in 2 a variation of that in multiple dimensions, right? So let's see how x looks like. Print x, we can see that. Okay, so this looks, this shows that we have, if you see here, this is a 3-dimensional array, right? It has if you see this, each array, individual array has only 2 elements, right? And then we have 8 rows, and then we have in the next dimension we have 5 such things. So this is a 3-dimensional array. So let us look at x dot ndim and see what happens. Yes, so this shows that we have a three-dimensional array. Now let's look at the various data types in TensorFlow. So let me create a variable. So in any programming language, you will come across data types. Could be int, float, boolean. So TensorFlow has similar concepts. We create a variable 1.0, and we can, in the last previous time when we created a variable, we did not mention a type. Here in the variable, we can also specify a type. It's by d type. So tf dot float 64. So we can mention different types. We can mention, if we go to float, we can use tf float 64 or float 32. Similarly, in int, we have int 32 or int 64, depending on how many what resolution of what precision you want with that number. Okay, so if I print x, you can see that it has a corresponding d type. Now let's try to convert. Now similarly, we can create int also. So if I have to create int, I can just say x equals tf dot variable 7 comma d type equals int 32. This will create a variable of type. Okay, I missed the tf dot int 32. So this creates a variable of type int. If I print x, you would find that it has a variable of d type int. Okay, this is how we will create and also observe the type of a variable. Now let's try to convert one type to another. It's very common in any computation to convert from float to int or vice versa. Of course, there are some repercussions. You might lose precision in some cases, but nevertheless, let's try to convert from one type to another. So let me create a float variable tf dot variable. Let me say 5.6 d type equals tf dot float 64. Okay, so I'm creating a variable of type float. Okay, float x. Let me type float x and see, confirm that it has a value 5.6. right? Now let us try to convert this float into an int variable and see what happens. So int x, I will say tf.cast. Okay, tf.cast is used to convert from one type to another. If you see the documentation, you can convert from one type to another. So first argument is the value which we want to convert, and next type is the target d type. This is the type which we want to convert. Let's try to convert int 64 from float 64 to int 64 and see what happens. Okay, so let me run this. Let us run int x. Let's see what happens. Okay, so it has converted. It has converted from float to int. We can see d type is int, but see the value. Since we are converting from float, it has a value of 5.6, and we are converting to int, we have lost the decimal point, and we can see the value is 5. Okay, in some cases it might be required. So this is how we convert from one data type to another. So next, let us look at operations on tensor. So once you define a tensor, there are a lot of operations we can do, and very helpful when we are building models. So let me define a tensor. A equals tf dot constant of 8. Let me define a tensor 8. Let me define a tensor. Okay, and let me define another tensor. B equals tf dot constant of 20. Okay, so two tensors have been defined. Let us say we want to add these two tensors. I will say a plus b. So what happens if I try to add these tensors? Okay, so we can add a tensor just by using the operators. We can use operator plus, we can operator minus. So all these arithmetic operations are possible. So we can see that 20 plus 8, the value is 28, and the d type also has been maintained. So this is how we can do basic operations using tensor. Now let us try to create a one-dimensional or a two-dimensional tensor. Let's try to create a different tensor this time. Tf dot ones, let's say 1 comma 2. Okay, I'm creating a tensor. Let us see what happens. Okay, so I'm creating a tensor here. Now let me create another tensor, y equals tf dot ones. Let me again create tf dot ones 1 dot 1 comma 2. Okay, I'm creating another tensor. Now let us try to add these two and see what happens. X plus y. I will just say x plus y. I'm trying to add two tensors. Okay, fine. We have added these two tensors. Similar thing could be achieved by using tf dot add. Let's say I say tf dot add x comma y. So we can also add using tf dot add, right? So we can achieve similar. So we can see the tensors have been added. It's all ones. The shape also has been retained. When we add or subtract, the shape of the tensor is retained. Only the values will change correspondingly. So we can also say tf dot subtract and let's say x comma y. So we are subtracting two ones, right? So we should expect all zeros. Let's see what happens. Yes, so we're getting all zeros. The shape has been retained. So we also have corresponding add and subtract. Okay, let me try to multiply a different shape. Okay, tensor of a different shape. Let me say tf dot ones of 1 comma 3. Okay, so let me try to run this and see what is the, how does v look like. Okay, shape 1 dot 3. Okay, now let's try to do tf dot multiply x comma v. Okay, we see that is giving an error, incompatible shapes. tf dot multiply actually performs the dot product of two matrices. Okay, so since it is doing dot product means element wise multiplication, hence the shapes have to match. Shapes of x, the first tensor and the second tensor have to match. Now let's try to do a matrix multiplication. There are two ways to multiply a matrix, right? One is the dot product and second is the matrix multiplication. So let us try to do tf dot lin algebra dot matmul of x comma v. Okay, x is of shape 1 comma 2, v of shape 1 comma 3. Let's try to do a matrix multiplication of, okay, x comma v is not allowing because again they are incompatible. Okay, let's try to do tf dot linalg dot matmul of x comma y. Okay, both x comma y are of the same shape 1 comma 2. Oh, this is also not working. Okay, so note that even if both the shapes are same 1 comma 2, dot product worked, but matrix multiplication did not work, because in matrix multiplication the concept is we take the first row of the first matrix and the first column of the second matrix and do a element wise multiplication and then sum them up. Okay, you can look up matrix multiplication how it works. Generally, for this to work, the last dimension of the first matrix 2 in this case should match the first dimension of the second matrix, which is 1. They're not matching. Let me create a new vector. Let's say z equals tf dot ones. We create a matrix of size 2 comma 4. Okay, now if I print z dot shape, the shape is 2 comma 4. Remember, the shape of x is 1 comma 2, so the last dimension of x is matching the first dimension of z. Okay, now let's try to do a matrix multiplication of x and z. So tf dot linalg dot matmul x comma z. Now this should work. Okay, this is working, and we can see that the shape is 1 comma 4 because it takes the first dimension of x, last dimension of z, so that is what the final dimension will be. Okay, this is how matrix multiplication we can do in TensorFlow. This is very important because generally we do a lot of multiplication when we try to build models. Next, let's see how do we reshape a matrix. Let's say we saw here that that v was not compatible, right? The shape of v was not compatible. Now let's try to change. Let me do v dot shape. V has a shape 1 comma 3. What if I want to reshape this this matrix? Okay, let's take a different example. Let's say v equals tf dot ones of, let's say 3 comma 4, because it's clear to understand. So I've taken a tensor with a 2-dimensional tensor, and let's try to reshape this. Let's say I don't like, I want some operation, I want a different shape. Okay, let's do a reshape operation. The first argument is the tensor which we want to reshape, and the second argument, okay, where we want to reshape this, the dimensions to which we target dimensions. Okay, so let's say 2 comma 6. What happens here? So what happens here is the initial okay, it says tf dot reshape. So we already had a tensor of there's something wrong here, give me a second. This is v. Okay, so let's try tf dot reshape. So what happens here is the first, initially we had a dimension 3 comma 4, then we want to reshape it. Okay, I think it will be clear if I try to print the v. Okay, and let's see how it looks like. So before reshaping, okay, it had 4 columns and 3 rows. After reshaping, it has 6 columns and 2 rows. So essentially it has reshaped the tensor. However, the point to note here is total number of elements. Okay, we have 3 into 4 is 12, should remain same. Now let's try to see what happens if the total number of elements does not remain same. Let's say I want to do 2 comma 5. Okay, in this case it should not allow it. Yeah, invalid argument. We can see that the error is requested shape has 10. Okay, which means in this case total number of elements is 10, but actually it has to remain constant. It has to remain as 12. So that's how we do reshaping, and reshaping is very useful in various when we want to do some operations. Another matrix operation that we should be aware of is transpose. So let's say I try to transpose v. So v, we know, is 3 comma, has a dimension 3 comma 4, 4 columns and 3 rows. Now if you do transpose, it will do a matrix transpose. It will convert rows into columns and vice versa. So if you see a transpose, we can see it as swapped 4 columns of 4 rows and 3 columns. Okay, it has swapped the rows and columns. So this is a very useful operation in matrix related operations. Now let's see a small trick to convert NumPy to TensorFlow and vice versa. Remember, when we try to work, when we're working on building a model using TensorFlow, the initial data, the source data, could be in different form. It could be in NumPy, it could be a NumPy array, and we want to convert it to Tensor, and then maybe we want to run the operations on Tensor and get the value back in NumPy. So we want operations back and forth between NumPy and TensorFlow. So let's define. So we already have we have tensor v dot numpy. Okay, this convenient method will give us a numpy array. So we see that v was a tensor earlier, right? Now v became an array. So this is how we convert numpy TensorFlow to numpy. Now let us try to convert a tensor. Create a tensor from a numpy. Okay, let me create a numpy array. Let me create a numpy array x equals np dot array np dot ones. Let me see, it's easier to create. 3 comma 4. Okay, let me try to print this X and see, confirm that what is the size of numpy array. Yes, it's a numpy array, 3 rows, 4 columns. Now let me try to convert this to tensor. Tf dot convert to tensor. So this is the method we can use, function we can use to convert from a numpy array to a tensor. So we can use x comma d type. We can specify a d type, what d type it is, right? In 32. Let's say we want to convert to in 32. Yeah, there we go. So we got a tensor. So we got a tensor of shape 3 comma 4. The same shape, and we got the same type as well, right? So this is how we convert TensorFlow to NumPy back and forth. So this is pretty much about the fundamentals of TensorFlow, what are the basic concepts of TensorFlow, how to get working, what are tensors. In upcoming videos, we'll see how to build a model using TensorFlow. That's all for today. I hope you liked it. Thank you for watching.